मैं तो नहीं दिखूंगी।
Hello everyone, a very good evening to all of you. Welcome to the webinar series on Vogue of Embedded System Day 2 under the Aegis of Texas Instrument Innovation Lab VCET Vasai. A large number of students and faculty are benefited till date from the training and other activities of all disciplines of engineering. I hope you have learned a lot from yesterday's webinar, and I am sure that you will be greatly benefited by today's webinar by Mr. Dilip Balasubramanian on robotics. I congratulate the organizing team, Mrs. Shaista Khanam, Mrs. Ruptisha, Mrs. Ektanai, and the great technical support provided by Mrs. Shraddha Goswami. I am thankful to the management of Vidyavardhini and Principal Vidyavardhini for constantly supporting and motivating us, and my colleagues in the department, they always encourage other TI activities. Thank you very much. Hope you enjoy the webinar. Thank you.
Hi everyone, I hope I'm audible. I think there was some audio issues with Tukti ma'am's system. So good to be between all of you. It's a pleasure to be among a lot of these people. Thank you. I'd like to start with thanking Vikas Gupta sir, Shaista ma'am, Trupti ma'am, Shraddha ma'am for organizing the whole gig and inviting me to be a part of it. Um, so it's apparently a 3-day thing, and yesterday you guys were a part of a smart manufacturing uh, webinar, not seminar. Um, and today I'm going to show you all, how to go and play around with robotics. But before I jump into that, I'd first like to know if all of you all are safe and sound in the middle of the pandemic. I hope everyone is tucked in at your homes and doing well. Perfect. Um, Great. So, can we begin? Is that a good time to begin? All right. All right. So, before we begin, I'd like to address a couple of things, right? I'd like to address the fact that uh, so who is this presentation for? Who's my target audience? My target audience is mainly students, enthusiasts, people in the corporate, people who are freelancing in other domains, who would like to understand the journey of how robotics got to where we are, and the journey of which you can embark upon to become a robotics enthusiast or a robotics engineer. I have I'm personally not a huge robotic developer, but I have worked around with a lot of people who are in the robotics domain, and a bunch of people who I worked with are officially working with Tesla, with big companies in the robotics, and they're doing really good. So I feel, having been in the technical training industry for for around 5 to 8 years, I feel qualified enough to officially present to you all this little thing that I prepared for. So what can you expect out of this? I'm going to take not more than an hour. All right. I'm going to take like probably 45 minutes. I'm going to keep some time off for question and answers. um, so here's my game plan. Here's what I'm going to do, right? So I'm going to begin with a couple of stories. All right, I'm going to begin with a couple of stories, and just to put things into perspective, just to give some context to what we're doing. uh, we are going to look at three main things: the advent, the application, and the future of robotics, right? And then we'll of course move on to interactions. Okay. um, for those who do not understand what I mean by advent or applications or future, um, we'll get on with that. All right. And also, before I begin, I want to just give you a small disclaimer that whatever I'm going to state is personally my opinion, and it's my personal thoughts that I have formed after being around in the industry, looking at a lot of different things for a bunch of years. And by no way am I going against or defying anyone else's opinion. I'm just putting forward mine, right? Because that could be uh, an issue. Sure. So, yeah, like I told you, the game plan is basically I'm going to divide the whole presentation into three parts. There's going to be the advent, application, and future. But uh, before that, I'm going to tell you a couple of stories. Story number one. Cool. Uh, Story number one begins in the Mumbai airport. All right, and it's not even Mumbai airport; it's Bombay airport, because story takes place somewhere uh, uh, in the late 90s, around 97, 98 sort of thing. And there's a guy who's waiting for a flight, probably really well dressed and looks rich. And there's another guy who's walking around in the airport with a briefcase in his hand and a really cool and shiny watch, right? And they happen to probably meet at the same coffee shop or something, and they struck a conversation. And so this guy with the briefcase, he basically told that he's from Japan, and he's here to on business. And this guy, the Indian guy, he asks him, "Well, what's your business?" And he says, "So my company is manufacturing smart watches, and that's what I'm here to sell." All right, interesting. So what does your smartwatch do apart from showing time? Because that's what watches are meant for. So the Japanese guy replies, "My watch can show you the temperature, the weather around you, the climate, and apart from that, there's one additional feature in which you can place a radio call using my watch. There's one button. If you click that, it transmits your audio in a particular frequency, so you can talk to someone over a distance who's tuned to the same frequency. So this is not just a watch; it's also a walkie-talkie and a thermometer sort of thing." He's like, "Wow, that's really cool. How much does it cost?" Uh, Considering the you know standard of living in 98, 99, the watch costed somewhere around 5,000, 6,000. It's my ballpark. I don't even know. This story is uh, repeated over the years, and this is probably like third, fourth hand knowledge to me. All right. Uh, so this guy finds it fascinating. He wants to pitch it to his company. He can take a franchise and probably grow his business. So he buys the watch as a personal used case. He wants to try it, and he wants to see how good of a utility it is. So he buys the watch, and he writes a check for 5 6,000 rupees and gives it to the Japanese guy. The Japanese guy walks off, and this guy calls him, "Ki boss, I think you're forgetting your briefcase. You just left it here." And this guy says, "No, no, no. The briefcase is a part of the deal." She's like, "What's in the briefcase?" He says, well, the briefcase basically has the charger to the watch and the antenna for the radio communication. All right. So a little watch requires a charger and an antenna the size of a briefcase, right? And the timeline for this is somewhere around 1999. All right. That is story number one. It's kind of a funny story because think of how, what a bad design it would be if you had to carry a huge briefcase around whenever you want to find out or talk to someone, right? Story number two, probably around 2015. All right. 2015. Forgive my writing. um, I'm using a tablet PC to write. So uh, 2015, Target Store is a huge brand in the United States, and it's like your DMart, Walmart sort of place, right? At the Target store, you can probably buy clothes, buy groceries, buy a lot of different things, pharmacy, buy I don't know, books, bunch of things. Um it so happened that Target store floated a scheme wherein they give you a card, and after completing your shopping and making the payment, if you show them the card, they'll add some additional points to the card, and based on the points that you get, you can probably get some discount or whatever in the next shopping round. And to make things even more interesting, what they did was they started sending out messages to their customers saying that, um, so you have these many points, and if you invest those points in buying cloth, or in, I don't know, buying groceries, or in buying books, we can give you a big discount. uh, that way they can also promote their cloth or books or whatever they're selling. um, so it went really well. It went really well. A lot of people started going to Target store. It was a customer acquisition trick, and a lot of customers came to Target store because of the extra points and because of the discount they used to make, and it was very exciting until one day, uh, this guy started getting a message saying, you can use your discount to buy contraceptives and uh, condoms and stuff like that. And uh, this guy is basically, he lives with his wife and two daughters. He's kind of old guy, and he's not really going to use any of those. So he calls up Target store manager and he tells them, "Ki, boss, this is not cool. You guys are sending me stuff like this, and I'm not really all that into these kind of stuff. I have a couple of daughters, and you might just end up making things very awkward with my family." And the Target store manager apologizes profusely. "I'm very sorry that this happened. I'll make sure that it doesn't happen again. Please forgive me, and here are some additional points so you can buy whatever else you want, right? Probably groceries or whatever." This guy's like, "Yeah, okay, cool, probably a glitch," and disconnects. Um, a month later, the same person walks into Target store buying something, and he again ends his shopping, swipes the card, and the manager and the uh, guy at the counter recognizes that this card had made a complaint. He checks the history and he finds out that, okay, he got like weird messages, and he again goes and apologizes to the customer personally, saying that, so last time around we had a conversation wherein you told us that you were getting messages about contraceptives. uh, I'm really sorry. I hope that stopped. And the person says, "No, actually it makes a lot of sense, because a month later I discovered that one of my daughters was having an affair and she got pregnant." Right. So the reason I'm telling both of these stories is, uh, we have gone from having to pack an antenna and a battery in a briefcase in 1999, and we have gone where a machine can actually identify our shopping patterns and tell us if about our life cycle, if we are pregnant or not, if we are sick or not, and stuff like that. In 2015, in a matter of 15 years, we've gone from you know, we, we have seen a huge paradigm shift in terms of uh, intelligence and machine intelligence. And so that brings me to my topic in hand, which is advent. Advent, the literal meaning of advent is arrival, right? How did robotics arrive into our lives? And you can find it almost everywhere, right? I don't want to get into the definition of what is robotics, or uh, which what can be classified as robotics, what cannot be. Uh, to keep things simple, I'll just say anything that makes your life easy. That anything that can be automated using a machine is a robot. Okay, जैसे पेन के निब से पैंट की जिप तक सारी चीज मशीन है. So in a very similar way, if you are automating something, it's a robot for you, right? Back in the day, you had to use hand fans, and today you put a button on and the fan goes up. That's robotics. Uh, so anything that is automatic and you can automate using technology is robotics. And so I'm essentially going to talk about the advent, application, and the future. So if you let's take a couple of steps back and find out, you know, the actual meaning of advent. Um, Application and future is basically past, present, and future. Okay, forgive my writing once again. So I'm a biomedical engineer. I have a writing of a doctor and the brain of an engineer. uh, Advent, application, and future is essentially the past, and you know how robotics or technology arrived into our lives. The present, which is where are we using it actively around us, and the future, where do we see it going, right? So the first point in hand is basically the advent. All right. um, where did it all start? Where did we start working, looking at technology very closely, because we did not imagine that we'll be using everyone will have a laptop in their houses, everyone will have a smartphone in their pockets. No one imagined this. People only thought that computers were good for big companies, big corporates. um, Probably a lot of, so it all boils down to one particular point in time in history where after World War II, uh, Roosevelt basically gave a lot of funding to universities, asked them to come up with something uh, which America can use to have a little fun. Okay, and at the same time in Illinois, Chicago, uh, at Bell Laboratories in the University of Illinois, John Bardeen basically made the invention of a transistor. Uh, for those who don't know what transistor is, that can be a couple of hours of webinar in itself. I don't want to get there, but because of transistors, we can have memory elements. Because of transistors, we can have uh, smartphones, whatever. We can have a lot of different intelligent things because we have semiconductors, right? Um, the whole silicon revolution that our industry went through is because of transistors. And John Bardeen invented the very thing that revolutionized an entire industry and the entire way that we look at things today. Uh, Today we are in the middle of a pandemic. Okay, we can't go out, we can't reach out to people, we can't really talk. The only medium we have is our laptops and our smartphones. Uh, and this was possible because of transistors. And the same thing happened in 1920. There was a plague attack and people could not really move out of their houses, and that was a really lonely phase for a lot of people. Whereas it's not so today, because in 1945 something happened, right? In 1945, John Bardeen came up with the transistor, because of which he got the Nobel Prize. Okay. Uh, and so computing began in itself. Okay, you initially had to use like large mainframes to make small calculations. If you've seen the movie The Imitation Game, you'll understand how big a mainframe is and how complicated just cracking codes was. All right. um, so this is what delivering a computer looked like in 1957. You had to get it out of a truck, all right, and it required like 15 people around that. It's like a bunch of people delivering a huge uh, uh, cot or a huge cupboard or a fridge to your place. Like it takes a lot of people and is massive. And this is basically delivering a computer in 1957. It's a image that went viral on Twitter a while ago. This particular model is called the Elliott 405. This was ordered in the state of, um, not really sure which state, but it was some forward-thinking chancellor started using this for some government purpose, and the photo went viral. And some guy took the opportunity in 2015 and went to the same place and you know took a photo. And this is what delivering a computer in 2015 looks like. You can hold it with two fingers, and this has more computational power than the thing that they got out of the truck. All right. So again, a while later, this photo went viral on Twitter. It's the same building, the same place, 58 years of difference, right? Almost 60 years of difference. And this is where we are at today. And how is it possible? Could you even imagine that something that would fit inside a truck, that would take a truck to fit in, uh, like in the 1950s, would fit on your thumb and your pointer in like around 2015? You could not even imagine. And it's all because of this little phenomenon that happened, which is called the Moore's law. I don't want to bore you about the Moore's law, but well, Gordon Moore was sipping his coffee one day and talking to his wife, and he just out of the blue told her that, you know what, I've been making some observations since John Bardeen invented the transistor. I've been observing that the number of transistors in a given area doubles once in every 18 months. So if today there are two transistors here, tomorrow there'll be, like, in 18 months there'll be four. After 36 months there'll be 8, 16, 32, and so on. That is exactly the reason why all of your the RAM configurations or your memory cards or your phones never see a 10 GB, 20 GB sort of thing. It's always 8 GB, 16 GB, 32 GB. It's because it doubles once in every 18 months, and it has held true till today, right? And they are expecting it to hold true for a bunch of other years. Probably the curve will flatten, and because your transistor can only be so small, it cannot be smaller than an electron. Right now we are we are in a single digit nanometer sort of thing. uh, we went from 15 nanometers to 8 nanometers, 7 nanometers. A lot of the race is on. People are trying to make it smaller and smaller. And when they asked Gordon Moore what to think about it, this is what he said. He said, well, frankly, I didn't expect it to be so precise. It's just like there is no scientific basis to it. There's no, it's only statistical, it's only observation based. I just wrote it, and it came to be called as Moore's Law. Okay. And Gordon Moore went on to invent a company called Integrated Electronics, and which is what we know today as Intel. And Intel is a market leader in processors and chips. And so why I'm giving you all this context is because I want you to understand how technology came into picture, the first thing. And because we have technology, we have robotics, right? uh, well, what took robotics to the next level is, frankly, these two things: the semiconductor revolution and the internet revolution. Because of semiconductor revolution, we could have processors, and we could have chips, and we could have sensors, displays, all of these things, because we have semiconductors. Uh, and because of the internet, communication became really easy, right? So these two are the most important two features because of which robotics is what it is today. All right. uh, you won't have sensors, you won't have chips, you won't have communication if you did not have one of these two things. So the biggest point or marking of arrival of robotics in our lives is thanks to these two events, right? Someday some guy made a transistor, and because of that, a whole industry was, the whole industry went through a paradigm shift. Uh, Similarly, the internet. So that's how robotics arrived into our lives. All right. uh, let's talk about where it is being used actively. Okay. uh, so I want to talk about problem solving. Okay. primarily, before I get into the applications of today, problem solving is so. Why would you use robotics for anything? Why would you want to use robotics to in your day-to-day life? Like, you can just do it, right? You can just do it yourself. Why do you want a robot to do it? uh, well, the answer is because uh, you want to solve some little problem, okay? Because it is too stupid for a human to do it, so might as well automate it, okay? Would you rather have someone with a fan sitting next to you and wave it at you, or would you rather automate it? Would you rather have a motor which is getting some electricity and which is running on itself, and the fan is moving and you're getting some air? So this is problem solving, right? So if you want to become a robotic enthusiast or a robotic engineer, uh, I will not ask you to uh, you know learn robotics by solving by looking for problems. I will ask you to learn robotics by solving problems and identify around you little problems. And so let me tell you how I got to where I am, right? um, just to give you a small example, when I was probably a student in college, when I was in my second year, third year of engineering, uh, so couple of different problems I solved using technology. uh, so for example, one of my cousins got pregnant and she gave birth to a baby girl, okay? And the problem with the baby girl was that she used to pee in her pants. You can't really control that, okay? It's a baby. And because no one used to really uh, check her pants if she's peed or not, she used to stay in that for a long time, and she started developing rashes on the skin. And that was really toxic. Should not have let that happen. So what is the solution? You would ask me. The solution which the doctor proposed was that, well, keep checking once in every 2 hours. Keep checking if she's peed or not. Well, and when my cousin was busy, I had to keep checking, and it's not really it was extremely futile. Uh, and when I had to solve the problem, and I was just learning technology and just learning robotics and how to solve problems using robotics, I quickly went to the market. I bought a moisture sensor, I bought a buzzer, I got a battery, I hooked it up, and I put it in the kid's pocket. And the next time she peed, the buzzer went off, beep 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 beep. And my whole family started looking at me like, what did you do? And I told them, no, relax, just check the pant, she's probably peed. So uh, little ways of solving problems. So one of my friends, what he did was, so problem with his family was that his grandmother used to fall down in the washroom and stay there for hours together before someone could come and help her. So he took a little accelerometer and took a little buzzer to that, and tied it together in a sari or something. And the next time she fell down, the z-axis became zero, and the buzzer went off, and everyone in the family knew that something was wrong, right? So you look for problems around you, solve for problems around you. Do not try to build a humanoid robot the moment you get into robotics. That should not be a target. uh, it is what you learn from your day-to-day trivial problem solving that will help you to build a humanoid robot, right? Okay, enough about that. Where is robotics being used massively today? uh, I'd say a bunch of sectors, like these are like honorable mentions, right? There are a bunch of, there are actually around 20, 30 different sectors I want to talk about, but I'm only given an hour, and we can probably connect offline if you're interested. But let me mainly focus on this, right? The manufacturing is one of the biggest markets for robotics. I have not seen a market bigger for robotics than manufacturing. Um, a lot of manufacturing is happening around the world. People are manufacturing in huge scales, and there are things that are harmful for a human being to manufacture. Robot solves a lot of problems in that. So, for example, if you are going to, it is extensively used in mining also, okay, where human life is in danger. For example, if there's some poisonous mineral which a human being can't really access, something happens, you can probably have a robot fetch whatever minerals are there in the mining industry. Uh, so there are a bunch of industries that I haven't spoken about, but I want to throw light on manufacturing. I want to throw light upon personal assistance, which is getting there as we speak. Process management. I want you all to understand process management extremely carefully. Logistics and healthcare. Let me talk about these things. Right. I'll not take a lot of time. Manufacturing, uh, one of the biggest domains where robotics is being used every single day is manufacturing. Uh, the best example I can give you is the Gigafactory, right? The Gigafactory, which is used by Tesla to automate the manufacturing of their cars. Uh, there's the Gigafactory, which is basically there are less than 25, 30 human beings, and it manufactures batteries for I think solar cells for a bunch of things. It manufactures batteries and stuff for Hyperloop, um, Tesla, SpaceX. A lot of these things, a lot of these Elon Musk companies are using a lot of raw materials, and all of these are being manufactured in factories called gigafactories, where tons and tons of robots. More than me explaining to you what gigafactory is, I would ask you to go on YouTube and just type gigafactory and just blow yourself off, right? Massive. So if you want to get into robotics, uh, getting into the manufacturing is one of the best way to do that, right? And if you are doing manufacturing and you're not using robotics, well, you're losing out on something massive, right? Um, Personal assistance is also getting there as we speak. This is the Mitra by Inventor Robotics. Uh, Very interesting. If you are big on Quora, you should check out Balaji Vishwanathan, who is basically the founder of Inventor Robotics. And this particular robot is called MITRA, and it's apparently an acronym. I'm not sure. I don't remember the full form, but yeah, uh, this happened where our Prime Minister met Melania Trump, and the whole event was probably launched with the help of Mitra. Uh, Personal assistants, you can also say Alexa or Siri, or all of your assistants are robots, right? They're also playing you songs, giving you recipes, and taking on your bad jokes one at a time. They're also your robots. Personal assistants is getting there. A bunch of restaurants in Bangalore are have started experimenting to serve food using robots. Uh, it's getting there, but I don't see a lot of growth in this industry in the next 20 years. But 20 years down the line, probably it will be big, because we are in the very nascent stage of understanding what services to be offered, what services not to be offered. uh, I can probably program my robot, because uh, if you have read some Isaac Asimov, you might know the three laws that a robot can't uh, you know that a robot will not have to abide by, will not break. And it cannot say no to a human being, it cannot harm a human being. And there are a lot of places where it can be misused, a lot of loopholes. More on that later. um, Process management is something that you all should, being in the college right now, you all should actively look at. So there's a huge industry called RPA. RPA stands for Robotic Process Automation. And RPA basically uses programming and algorithms to efficiently solve a lot of problems. For example, a little example I've given in front of you. The customer service representative. A customer service representative is someone who basically takes care of a customer journey, right? Has the customer placed an order? Is the customer new, or is an existing customer, right? Should you schedule a delivery? Once the delivery is done, a customer will. So once you order something on Amazon, you get an automated email. Once you order something, once it is delivered to you, you get an SMS saying it's delivered or whatever. So all of these things are not done by a guy who is sitting there. Okay, they are processes which are automated using robots. And while robot, I'm not saying it's a bot which is sitting and typing. It is basically a server based algorithm which is constantly running. uh, RPA industry is extremely new and nascent. Um, there's a there are a bunch of certifications being offered in RPA which you should check out. Uh, it is going to be huge. It is at the moment, since it's very new, it's extremely expensive. You can find RPA services in the Azure cloud, in the probably AWS has an RPA service. Uh, I have personally taken an RPA training on UiPath. UiPath is an extremely interesting interface for RPA. You should check this out. Robotic process automation is also, so the bots. For example, you must know that Instagram bots and YouTube bots, which will automatically start, clicking on stuff or liking or commenting. All of those bots are also robots, right? I want you all to really check RPA out. Get into it probably, and uh, you know understand the industry and help us grow together, right? Logistics, yes, definitely I can see this happening given the situation. uh, Given there are certain guidelines around it, and if you do it in a secured manner, the all of these things are definitely coming through. Okay. uh, and while I say logistics, it's not only a drone delivering a package. It can also be a driverless car. It can also be, for example, if something is wrong with your car, and uh, you know you can automatically shift it to a robot mode where it will automatically debug and tell you what is wrong with it. Or so Aether has launched a scooter which has built-in Wi-Fi and built-in lot of interesting interfaces. It will find out what is wrong with itself. It will schedule a checkup. It will schedule a maintenance check. It will automatically tell you. So all of these things are bots as well. Uh, so robots, yeah, definitely. Amazon has a sorting center. So Amazon receives billions of parcels every day, and it is very difficult for human beings to sort these parcels based on regions, based on I don't know, weight, based on a lot of different parameters. And for all you know, a lot of these parameters are also a lot of these activities are also taken care of by drones, or by bots, and bunch of things. And one important, extremely important place where robotics is playing a massively important role is healthcare. Being a biomedical engineer myself, I understand how important it is for a lot of healthcare activities to be automated, right? The thing that you're watching on your screen is called it's the Da Vinci bot. Okay. Which is basically, it'll not automate surgeries. Well, you can technically do that, but uh, the problem with the healthcare industry is that there are a lot of compliances, a lot of legalities. If you allow a robot to do a surgery, um, the next day, like billion lawyers will come knocking on your door, patent infringement, a lot of laws around it. Uh, so it is being controlled by a doctor. Essentially, the doctor is doing a surgery. Okay, so that's a workaround. Uh, there's a friend of mine works in a very interesting company which is basically working on robotic arms for uh, surgeries. It's called Verb Surgical. So Verb Surgical is a startup by Google and Johnson and Johnson. All right, and these two companies together started a company called Verb Surgical to automate healthcare processes. And uh, Google completed their liabilities, and Johnson and Johnson has completely bought out Verb Surgical, and it is in the US. And a friend of mine is an engineer who works at Verb Surgical. Extremely interesting line of role. And when I spoke to him right before this webinar, I spoke to him, and uh, I found out that what they are trying to do is they are trying to replicate the kinematics of a human hand inside a robot. So a lot of different reflexes because of the muscles that happen in our hand. They are trying to replicate that on a robot, which is extremely interesting to me, and which is going to change a lot of the game in the robotics. Uh, I'm going to rush through the next little part because I want to have enough time for Q&A as well. The future. Where do I see the future going? It, so it is really difficult to pinpoint the future given the situation and given you know the fact that we have been innovating at an extremely rapid pace. Okay, the speed at which things have come around is extremely fast. Okay, for example, when I was a kid, I'll not say a kid, but when I was like a teenager, probably when like 2005 or 2006, I used to play Pac-Man and Super Mario on my computer or on my video game. And today, in a span of 10 years, in 2015, 16, you'd say, we have VR gaming and we have immersive reality where you think you are a part of that game. Okay, so gaming is just one example I'm giving you because students will understand that better. But we have gone from Pac-Man to VR based Call of Duty in like 10 years. It's nothing. And to go from nothing to Pac-Man took us like, I don't know, 2000 years. All right. So you see how exponential the graph is going. Okay, so it's super difficult to pinpoint where the future is going, but there are some things that I want you all to check out. Internet of robotic things. What is very interesting is that if you know what internet of things is, uh, you can develop robots to actively get interfaced with internet of things. For example, uh, Alexa is an Internet of Robotic thing. Okay, uh, so what I mean by Internet of Robotic things is basically given a robot, it will have a lot of sensors around. It will have a bunch of actuators around. These sensors and actuators are basically defining what the robot is going to do. Okay, uh, now if there's uh, if there's an interface of Wi-Fi in it or internet in it, okay, you can essentially uh, control the actuators from the internet sitting at home, uh, or you can essentially uh, read the sensors sitting at home. Okay, for instance, let's say you're in a car, you're going home, and you want your room to be cold, so you are going to sort of do something which will turn on the AC. Okay, but how do you know if the room is already cold or not? So you will first check the temperature of the room, and depending on the temperature you will set it to something else. So when you are checking the temperature, that is sensing, and when you are setting it to something else, that is actuating. So two important things in robots which are going to sort of lead the IoT revolution inside robotics is the sensors and actuators, and this is true even for software bots. Okay, depending on what their application is and depending on what their purpose in life is, they sense and actuate some stuff. And IoT revolution is coming. Another revolution in robotics is the AI revolution. All right, artificial intelligence in robotics, extremely paramount importance, I'd say. uh, this is a phenomenon. If a robot can self balance by learning, that's a phenomena. Okay, what Tesla is trying with driverless cars, or what you can try, is basically to uh, have an element of machine learning, have an element of AI in your robot, which will essentially help it think on itself. Okay, learn from its mistakes. AI is nothing but replicating human intelligence. Okay, uh, for example, when you are a baby and you don't know different terrains, you are walking on a slippery surface, you're walking on stairs, you're walking on a mountain, you're walking on a road. There are two four different experiences, and when you walk on the road, it is pretty straightforward versus all the others. So with each experience, you're learning and you're adding that to your database, and you're recalling it whenever you're on a different terrain. So uh, you have to basically do the same thing to a robot. You have a little memory, and you basically feed some data inside that memory, and as you sense, you keep feeding all these experiences into the memory, and you recall these experiences whenever you want to make the next decision. A very common example of this, uh, it may sound dumb, but it's very interesting, is a robot playing chess with you. A robot playing chess with you is so this form of artificial intelligence is called reinforcement learning, right? So reinforcement learning is when, after every move that you make, the robot goes back and checks which is the best move to make, and it will implement one of those. Okay, the robot will understand how intelligent you are. Depending on that, it will give you some difficulty level also for the next game, and after every move, the robot will do a lot of back and forth, and before deciding what move to make. So the AI revolution is coming, all right, and it's coming pretty quick because a lot of companies are, actively, making uh, their companies data driven, bringing machine learning, artificial intelligence in the picture. Uh, that is, if you are a robotics scientist, you should really take a close look at machine learning and artificial intelligence. One of my friends, uh, who used to work with me at Eduvance, uh, has gone on to do his master's in robotics from Worcestershire University, and he's now working with a company who is, identifying uh, facial recognitions, or so he's doing image processing, right? And lot of interesting things coming up. I saw a little post in LinkedIn wherein you can basically, on the street there's a camera, and the camera is basically finding out people and distance between them. Okay, uh, which is a social distancing problem. And whenever two people go closer than, whatever 6 feet or whatever the metric is, it will mark them red, and it will keep tracking them, and it will find out if, if they are going to collide or whatever. A lot of traffic light signals are working on identifying number plates and where they are coming from and stuff like that. So things are moving in the right direction. Robotics in domains is one thing I wanted to talk about. uh, in what domain should you involve robotics more and more? Okay, is, in my opinion, the biggest, being in India, and being a student at this point, I think we should think about nothing more than agriculture. Okay, agriculture is an industry which requires, so India is the brain capital of the world, all right, and India is also like the agriculture capital of the world. And if we are not innovating, and if we are not applying our technology in agriculture, what the hell are we doing? Okay, we have a reputation to maintain, and it's up to you all to maintain that reputation, and bring up the technology. A lot of people are actively working on agriculture. They are working on, using drones to spray fertilizers, automating irrigations, and a lot of those things. But uh, definitely a lot of attention is required in that domain. The second domain I want to talk about is education. Okay, robotics in education, extremely interesting. Eduvance, as a education company itself, is working on a lot of robotics applications in education. We have set up remote labs, wherein, let's say, you want to access a hardware and you don't have direct access to it. We have created a system wherein you can remotely access, you can Skype with the hardware. We have created, an online assessment tool where you can just write a program and upload it, and the computer, our robot, will basically check if your program is, optimized or not, is logically correct or not, syntactically correct or not, and it will tell you what is wrong with your program, right? Uh, So we are in so we've started using augmented reality and virtual reality for education. Our technical team uh, is actively and immensely innovating in developing applications for you to understand how mechanics works, how engineering drawing works, how electronics works using AR and VR, right? So for example, engineering drawing is one subject where a lot of imagination is required, and if you can't visualize it, you probably can't draw it. A lot of people end up copying in all of these papers, right? So what we have done is we have an application which will in 3D, in three-dimensional space, it will basically simulate the whole drawing, like point A, point B, connect these 2 points, draw an angle, draw a line at 45 degrees, connect them, and all of those things. uh, it happens in 3D space, and you can basically look at the phone and you can replicate it on your papers. A lot of interesting applications coming through. Education is one space where we are actively innovating, but we see there is not enough innovation in the industry. A lot of people are only working on, let's make a online video platform, let's make online videos. Well, that will help definitely, but that's not going to solve a lot of problems. Education needs to be looked at more carefully. Commerce, uh, the way we do commerce also needs to change. I think there is scope for a lot of improvement in the way we do commerce. And by commerce, I'm not just saying calculations in mathematics. I mean shopping. I mean payment and stuff like that. Uh, we can somehow revolutionize these domains. It will be really interesting to look at. How to get started? Uh, I'm going to keep this short because I only have like 5-10 minutes left. Um, I hope it's okay if I take 5-10 more minutes, ma'am. Yeah. So, how to get started? Um First thing is get some motivation. All right. Uh, I'm not going to talk about that a lot. Basically, you go online, get a lot of motivation. You come to webinars like this. You talk to me more. I'll give you more motivation. That can be a separate conversation. Online resources. You have access to YouTube. You have access to Coursera, edX, NPTEL. You have a lot access to bunch of other like different things that are out there and free of cost and accessible. Go get something and learn. But personally, the favorite way that I opt for is to getting your hands dirty, to actually getting down, buying some sensors, buying some hardware. Basically, any problem can be broken down into three basic steps. All right, any problem in your life, including I don't know, girlfriend problems, boyfriend problems. Any problem in life can be solved in three different steps. And let me give you a bunch of different examples. Let's take the human body. Okay, uh, there is some input, there is some processing, and there is some output. Okay, that's it. There are these are the three blocks you have to handle. Okay, for example, you eat food, that is input. You digest it, that is processing, and you take it out of your system, that is the output. By taking it out of the system, what I mean is I can talk because I have energy because of the food, right? uh, for example, you see what is the temperature in this area. You process this fact that the temperature is whatever, 30 degrees, 32 degrees. Depending on the temperature, you turn on the fan or you turn on the heater if you want to maintain temperature, right? So basically all problems can be solved by using three basic steps: input, processing, and output. Okay, for input you are going to need some sensors. For output you're going to need some actuators or display devices. It can be your monitor, it can be a printer, it can be a motor, it can be an LED, it can be a bunch of other things, relay for example. And the processing, for processing you have a lot of different options, right? Let me talk about that. For processing, what you can do is you have access to your Texas Instruments lab. And before the presentation began, what I was looking at was a small presentation on Texas Instruments, and I saw there are so many platforms in your labs. The MSP 430 by Texas Instruments is the most basic thing that you can learn. Okay, using the Energia software, you can program it in a matter of minutes, and in like 5-10 minutes, you actually have an entire project ready. Okay, You have access to all of these things. You have access to the hardware, the sensors, the display devices, and your college is supportive. They are actively engaging people from the industry to come and share their knowledge with the students. All you have to do is identify a little problem around you and use these resources to solve those problems, and that's going to make you a really good engineer. Okay. uh, how do you go about that? If you have a particular problem that you want to solve, you can probably take it offline. I'm going to stop my presentation here by giving you my credentials, my where you can contact me. You can either leave an email on dilip@eduvance.in, or you can connect with me on LinkedIn, uh, which is linkedin.com/in/Dilip B. Iyer. Uh, I hope you all had fun.
Yeah.
Shaista ma'am, over to you.
Yeah.
If there are any questions
Yeah.
that I can answer.
Yeah, I'll also forward it. Thank you so much. Now I'll request participants to give your questions. And Dilip, I'm very happy to share with you that our Department of Electronics and Telecommunication has started a driverless car project. So
Wow,
students, like, it is in process, right? So like soon we'll come with it. So you have questions.
amazing.
So yeah.
Why is it called Gigafactory? Well, that is, why not use Pampers brand? Well, there are a bunch of questions that you can ask and you can answer. Uh, I made a bunch of decisions, and in the beginning of the presentation, I told you that all of these are my personal opinions and my personal decisions, and I think people would have solved it in different ways. I'm sure.
Yes, you can. Yeah.
Can you list some skills and tools that we can get to learn deeper into the robotics domain? Sure. Uh, Skills, well, programming is extremely important. It is of unparalleled importance. You have to know programming no matter in what domain you are. Don't be scared of programming. Get down and start working on it, and you will get all the solutions. Right? Uh, there is skills, uh, and also hardware skills. Uh, and tools. There are a lot of different tools that you can use. There is something that has just come up which is extremely new, like 2 3 years old. It's called ROS, Robotics Operating System. You can simulate, you can emulate, you can program, you can do a bunch of things using ROS. Please make sure that you check that out. What role does mobile robot play in revolutionizing the world? uh, Extremely important one, because uh, almost everyone has access to a mobile phone these days, right? uh, so how important is something in your life depends on how accessible it is to you, and how many people are using the same thing. Excuse me. Extremely important. From which website or company to buy hardware for robotics project, preferably Indian? Amazon has a lot of different, uh, Amazon has almost all the sensors you will need to build a basic project. Amazon will definitely have. If you don't have Amazon, if you don't have it on Amazon, you can check Moser. You can check Element 14 if you have a student ID, or if you are a corporate ID. Um if you absolutely have to import it from the US, you can always get in touch with someone who's there. They can find some channel to ship it down to you. What is the best place or best way to start robotics? Best way to start robotics is to find a problem around you, find some resources that you can use to solve the problem, and solve it. Also suggest a path that, like, slowly and steadily will help to get acquainted with concepts. Jatin, good question, yeah, good question. uh, However, I think rather than me giving you a path, it makes more sense when you decide some problems, you solve it, and by way of solving problems, you find out where you're going. Right? I cannot really tell you if your strength is programming or if your strength is hardware interfacing, electronics. I can't tell you what is your strength. I can't tell you if your strength is algorithm building or management or like commerce or maths. I don't know, right? So you have to identify your strength and work on that, and for identifying your strength, you can pick a bunch of problems and just try to solve it. And uh, how do you identify what you're good at is basically what makes you happy. If you're happy while programming, that's your thing. If you're happy while selling, that's your thing, you know. Some robotics online courses, absolutely. If you go on Coursera, University of Michigan is offering some incredible courses on robotics. There's a bunch of courses offered by Maryland University as well so there's one particular course I want you all to check out. It's called CS50, Computer Science 50 CS50. You can check it on YouTube also on edX, and CS50 is extremely exhaustive and informative for beginners. What kind of courses do you offer at Eduvance? Eduvance, right now at the moment, because of the pandemic, we have limited the courses that we are offering. But usually, we are offering courses on ARM-based controllers, embedded systems in general by Microchip, Cisco. Uh, there's a bunch of IoT trainings that we do. Uh, we also do robotics. We recently conducted a small program at Vidyavardhini on drones, how to assemble, build, and fly drones. We are also actively, so right now we are working on machine learning, Python, and data analytics. So if you want to get into any of these, if you want a good introduction to any of those, you can always get in touch with us at Eduvance. Any job prospects in robotics? Absolutely. Um a lot of things are getting automated. A lot of people tell me that because of automation, we are losing jobs, and it's counterintuitive. Let me tell you that. We all thought that when computer is going to come, a lot of people are going to lose jobs. As opposed to it, a lot of people learned computer programming, and like number of jobs increased, right? So similarly, with the advent of robotics, with the advent of machine learning and programming, the job industry is going to only become bigger and better. Can we say in the next 10 years the whole world will be run by robots? No, you cannot. And I will definitely not say that. It's in my opinion, because robotics is a revolution coming, but at the end of the day, uh, it can only be used to, do so much. You can't do almost everything. There are things that human beings need, like feelings and emotions, and stuff like that cannot be given by robotics. For example, I go to a particular store to cut my hair because the barber has a 1v1 with me, and that's a feeling that a robot can't give me, right? The whole world will not be run by robots. If you are worried about artificial intelligence, don't be. uh, I personally have a lot of faith in Elon Musk, and I'm sure he'll save us. Please provide where you can connect with you. You can leave me an email at Dilip, DILIP, @eduvance.in, EDUVANCE.in, or you can connect with me on LinkedIn. I'm sure we'll put a comment on the comment section with my connection details, so you can probably get in touch with me. All right, perfect. I hope that was informative. I hope that
Yeah,
was productive.
yeah, it was very informative session, sir. Due to technical issue, like your introduction is remaining. So first, now we are going to play again, and then we'll
No
continue.
problem. No
Yeah,
problem.
yeah.
Thank you, sir. Good afternoon, everyone. I hope you all are healthy and happy with your family. I, Trupti Shaha, Assistant Professor and member of Textile Instrument Innovation Lab (VCET), warmly welcome you all on behalf of Vidyavardhini College of Engineering and Technology on the second day of webinar on Vogue of Embedded System. This webinar is organized by Department of Electronics and Telecommunication Engineering in association with Texas Instrument Innovation Lab. I extend my greeting to today's speaker, Mr. Dilip Iyer. It's great pleasure for me to introduce our speaker, Dilip Iyer. He is a senior training manager at Eduvance. He is responsible for management development, allocation of training resources for various fields such as embedded system, machine learning, augmented reality, drones, and robotics. He is also responsible for end-to-end operations for training evaluation activities. He has developed industry level IoT based products which were displayed on cloud services such as ThinkSpeak, IBM Western, Studio, Cisco, Kinetics, and Eduvance platforms. He also has patents on system interoperability. He also has patents on system methods for interactive delivery of educational content and bike rider behavior monitoring system. Now I request Dilip sir to take over the session for today's webinar on application and future of robotics.
Thank you.
Thank you for
Thank
your
you.
kind words, ma'am. Thanks a lot.
Yeah, thank you so much, Dilip sir. Actually, I'm actually by your seminar, like you have given so many examples. Like we came to know about Gigafactory and which is used by the Tesla, and about this biomedical applications. So thank you so much, sir. And we expect your cooperation, like, and your help in a development of Texas Instruments Innovation Lab in VCET. So, on behalf
Absolutely.
of Vidyavardhini's College of Engineering and Technology, I thank you, sir, for coming and giving us your time. Thank you.
The pleasure was mine, ma'am. Thank you.
Yeah,
I hope everyone has a nice day. Thank you.
yeah. Thank you. Now, I want to introduce Texas Instruments Innovation Lab of VCET. VCET Texas Instruments Innovation Lab. Uh, Texas Instruments Innovation Lab in VCT was inaugurated on 1st March 2019. VCET lab, we have conducted many training programs on embedded system, IoT, robotics, and DSP applications. Till now, we have trained more than 150 students and faculties. VCT Texas Lab is very much active in providing the guidance for in IICDC project 2019, and we have organized a district online test also, in which we have a great participation of 500 students. So now coming to our webinar series, right? We have organized this webinar series under this Texas Instruments Innovation Lab. Now we have our 2 day session on webinar is over now. Now the third part is nothing but a quiz. So the quiz tomorrow will be having a quiz session, which is nothing but a journey of microcontroller. Now, the best thing or the special thing about this quiz is the first three winners of this quiz will be awarded IoT training in VCT Texas Innovation Lab. So, all the best, and important announcement that the quiz will be open tomorrow 4 o'clock, and will remain open only for 2 hours, 4 to 6. So, I expect a great participation from you. Thank you so much.
I hope you all find this webinar series in line with your expectation during COVID-19 period. I would like to take this opportunity to express my heartfelt gratitude towards all the esteemed speaker, Mr. B.A. Damai and Mr. Dilip Iyer, to enlighten us with their knowledge. A sincere thanks to our management and principal, Dr. Harish Van Kundre, for their motivational supports. I am grateful to our HOD and head of TI Lab, Dr. Vikas Gupta, for providing valuable guidance. A deep sense of appreciation for all the participants without whom this webinar would have been impossible. I would like to thank Coordinator Professor Shaista Khanam and member of TI Lab, Professor Ekta Naik, for continuous efforts in planning and execution of this webinar. I would like to mention special thanks to Professor Shraddha Gosavi, who was the pillar of this webinar. Last but not the least, I would like to thank all the faculties of EXTC department and TI Lab committee who supported us directly and indirectly. Thank you all.